Today we are going to develop a powerful new technique for calculating derivatives of complicated functions, and it's called the chain rule. So suppose that we have two relatively simple functions, f of x and g of x, that we know the derivatives of. What is the derivative of their composition? F of g of x. So for example, if f of x is the sine of x and g of x is x squared plus 1, what's the derivative of f of g of x, which is the sine of x squared plus 1? So here, the outside function f is the sine function, and the inside function g is x squared plus 1. Now, the following diagram should look familiar. It's one that we drew when we were talking about what a derivative was. And what it is a limit of slopes of a secant line. Delta y is the change in the dependent variable. Delta x is the change in the independent variable. The ratio as delta x goes to 0 is the derivative, and what's also clear from this picture here, as delta x, the change in the independent variable, goes to 0, delta y, the change in the dependent variable, is also going to go to 0. So now let's take a look at our composition, and we want to compute the derivative y prime with respect to x. We define an intermediate variable u equals g of x. And so u is actually the value of the inside function, and we're going to write this now as y equals f of u. So the derivative of y with respect to x is this limit that we just talked about up here. And what we're going to do is split this delta y over delta x into delta y over delta u times delta u over delta x. And obviously, the delta u's are going to cancel here, and you do get delta y over delta x. Now, property of limits, that's just going to be the limit as delta x goes to 0 of delta y over delta u times the limit as delta x goes to 0 of delta u over delta x. Now, as we saw up here, as the change in the independent variable goes to 0, the change in the dependent variable goes to 0. And in this expression, that's the dependent variable. This is the independent variable. So what we're seeing here is that when delta x goes to 0, delta u goes to 0 as well, which means that we can take this delta x goes to 0 and replace it with a delta u going to 0. Now, if we look at this, that's the definition of the derivative of u with respect to x. And this is the definition of the derivative of y with respect to u. So what we end up with here is dy du times du dx. And we can write the chain rule in this form. Dy dx equals dy du du dx. Now I should mention that this argument that I've given you here is motivational. It's not complete. The details could be fixed, but they lead to a more technical discussion that I think we want to consider at this point. So we have this expression, u is g of x, y is f of u. So this statement is y prime equals dy du, which is f prime of u, times du dx, which is g prime of x. And we can also write this as, now remember that originally y was f of g of x, so y prime is f of g of x prime. U is g of x, so this is f prime of g of x times g prime of x. And this is the chain rule. So what it says is the derivative of a composition is the derivative of the outside function f evaluated at the inside function g times the derivative of the inside function g. So let's pop back to our example. F of x was sine x, g of x was x squared plus 1, and y was f of g of x, which was the sine of x squared plus 1. So outside function, inside function. So we formalize that by setting u equal to g of x equals x squared plus 1, and then we note that the derivative of f of x is cosine x, so the derivative of f evaluated at u is cosine u, so this is a derivative with respect to u, and the derivative of g of x is 2x. Now, according to the expression we've got up here, we can write the derivative as y prime is f prime of u times g prime of x. That's the cosine of u times 2x. And u is x squared plus 1, so that's the cosine of x squared plus 1 times 2x. So we can write the derivative of the sine of x squared plus 1 is cosine x squared plus 1 times 2x. Okay, so in terms of what we talked about here, outside function, sine, inside function, x squared plus 1. Derivative of the sine of x is the cosine of x, but we get the cosine not of x, but the cosine of the inside function, now times the derivative of the inside function. So let's do another example. Y equals the square root of x cubed minus 3x, and now in these sorts of situations, you all want to write the square root of x as a power. Okay, so this is going to be x cubed minus 3x to the 1/2. And now look, inside function, outside function. So this composition can be written as y equals f of u equals u to the 1/2, the outside function, and u equals g of x equals x cubed minus 3x, the inside function. The chain rule says y prime is f prime of u times g prime of x, derivative of the outside function evaluated at the inside function times the derivative of the inside function. And the derivative of u to the 1/2 is 1/2 u to the minus 1/2. The derivative of g of x is 3x squared minus 3. And now finally remember that u is x cubed minus 3x. And this gives us our expression for y prime. Derivative of outside function evaluated at inside function times derivative of inside function. Now, the last problem, we had y was a power of some other function. And in this particular case, r was 1/2 and g of x was x cubed minus 3x. But this is sort of a general situation here. So suppose we have a function of the form y equals another function g of x raised to a power. Okay, so we're going to take the outside function f to be that power function. And we know that the derivative of a power function at u to the r is going to be ru to the r minus 1, differentiating with respect to u. So when we use the chain rule here, we get y prime equals f prime of u times g prime of x, which is ru to the r minus 1 times g prime of x. And we haven't specified what g is. But now u is g of x, so we get r g of x to the r minus 1 times g prime of x. Okay, so again, what we've got here is derivative of outside function, which is u to the r, which is going to give us an r u to the r minus 1, but u is g of x, times g prime of x. And that gives us a general formula for differentiating such expressions. Okay, let's look at one more example. And the example is y is the cosine of x over x squared plus 1. Now, the composition is y equals f of u equals cosine u. Cosine is the outside function. And u is going to be g of x, which is x over x squared plus 1. Okay, so we do the same stuff. The derivative of cosine is minus sine, so the derivative of this function of u is minus the sine of u. And now we need g prime, but g prime is a little more complicated. It's a quotient, so we need the quotient rule, and we just do that. So we get the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. We got a 1 here, and we've got an x squared minus 2x squared, which gives us 1 minus x squared on the top. So this thing is the derivative of g. And now we just look at the chain rule again. Y equals f prime of u times g prime of x. Sine of u times g prime of x. And now remember that u is x over x squared plus 1. So we get minus sine of x over x squared plus 1 times the derivative of x over x squared plus 1. Okay, so once again, derivative of cosine is minus sine, but it's not evaluated at x, it's evaluated at the inside function x squared plus 1, and now times the derivative of the inside function. Now let's take a look at a situation where we don't know the functions, but we know something about the function values and their derivatives. Okay, so f of x and g of x are described by this table. For the values x equals 1, 2, 3, 4, this table describes the values that f prime, g, and g prime take on. Okay, so the first question, if h of x is f of g of x, compute h prime of 1. So we write down the chain rule, which is h prime of x is f prime of g of x times g prime of x. And now we want this at 1, so we put in a 1, and we get f prime of g of 1 times g prime of 1. Now it's time to look at the table. And what we see here is that g prime of 1 is minus 2, and g of 1 is 2. So this becomes f prime of 2, which was g of 1, times g prime of 1, which is minus 2. Now we're not finished because we've got an f prime of 2. So we look at our table, and when x is 2, f prime is 5. So we get 5 times minus 2, or minus 10, as h prime of 1. Now let's look at k of x, which is the composition, but it's in the opposite order. Okay, up here, we had f of g of x. Here we have g of f of x. And we're supposed to compute k prime of 1. Okay, so it's a chain rule again. K prime is going to be g prime of f of x times f prime of x. Okay, it's just this expression with g and f reversed. So k prime of 1 is g prime of f of 1 times f prime of 1. We look in the table again. F prime of 1 is minus 1, and f of 1 is 3. So we get g prime of 3 times minus 1. And we have to look in the table again. G prime of 3 is minus 1 as well. So we get minus 1 times minus 1 equals 1.